Hello students, in this video I'm going to be going over the problem sets from lessons 6 through 8 in Unit 6. I'm going to be talking about the answers to questions such as, what is an angle bisector? What happens when three medians intersect? What is the triangle inequality? How do I solve this equation? All this and more in this video. Alright, take a look at the lesson 6 problem set. Hopefully you tried it already. I will ask you to pause the video for now and then unpause it when you are ready, and I will show you the answers to these questions. Alright, you'll see with all of these problems, the first step is to take a look at the information that they give you and draw a picture. It tells you in triangle ABC, these angles are the given angles, A, B, and C. And once you know the measures of the angles, you should use the triangle angle inequality, which states that the smallest angle is across the triangle from the shortest side. In other words, since this angle is 40, this side, AB, is going to be the shortest. Says this angle is 80, this side, which is AC, is going to be the longest. So looking at the answer choices, it says which inequality is true. Well, this is the only inequality. Choice 2 is the only inequality that correctly identifies the fact that AC is going to be larger than BC. Why is that? Well, we know that AB is the smallest, right? This one says AB is bigger than BC. That's not it. This one says AB is bigger than BC. Well, that's not it. This one says that AB is bigger than AC. That's not it. AB can't be bigger than anything else because it's literally the smallest side. In question number 2, we drew the triangle again. I saved you the trouble of looking at my sloppy hand drawing here. I just used the computer drawing program for that. Again, it gives us the information about the angles. It doesn't give us numbers here, but it does tell us that angle B is the smallest. So that means angle B is the smallest, which is across from the smallest side, AC. That tells us that AC has to be the smallest. If we're looking for the false statement, we're looking for the statement that is not true. AC can't be bigger than BC because, well, it's the smallest. We're using the same argument again and again and again. We're just identifying all the different angles, seeing which one is the smallest angle as across from the smallest side. Here we are only given 2 angles, but we use the triangle angle sum here. That's 180 minus the other 2 angles gives us the third. Let's see. Didn't do anything particularly tricky here. Number 5 is the same thing. Number 6 was a little tricky because it didn't give us the exact angles. It said this was 65 and this was going to be bigger than this one. Well, even if you guess 66 for this, which is one bigger than 65, then you can guess that this one is 49. It doesn't matter what you guess for this one because it's always going to have to be the biggest side of the biggest angle of the triangle. And this one's always going to work out to be the smallest. You can check that yourself by guessing other values. This could be 70 or 80 or 90, etc. Anyway, you can figure out which one's the smallest, the middle one, and the largest like this. And keep in mind that your picture, it doesn't matter whether it's correctly proportioned. Like this 65 and this 66, they look way different, but they obviously should be the same. Your triangles do not have to be drawn to scale. They just have to figure out which one is the smallest, which one is the medium, which one is the largest. In this one, I showed you a little trick. In triangle ABC, AB is equal to 7. Well, I know that if AB is equal to 7, then the vertex or the angle that's across from AB is going to be C. The vertex that's across the angle or across the triangle from BC is going to be A. It's the missing letter. And AC is across from angle B. So using that, I was able to tell that angle C was the the smallest angle. Angle A was going to be the middle angle, and angle B is the largest angle. There we go. In question number 8, we did the same thing. We took a look at the fact that angle A is congruent to angle B, while the missing letters are B and C. So BC is congruent to AC. And we're able to tell that angle C is obtuse. Well, if angle C is obtuse, that means it's the largest angle in the triangle, only one obtuse angle per triangle, and AB has to be the one across from it. So AB is the longest side, and AC is congruent to BC is our correct answer. Number 9 had a cute little picture of a river, but it's the same stuff, different problem. All right, take a look at the second page. Again, pause the video for a moment, and then I will show you the correct answers. All right, question number 10 should have been pretty straightforward. The first thing you did was exterior angle theorem. This angle, the exterior angle, is equal to the 2 remote interior angles. We did that and we found 80. The triangle sum theorem, which is all 3 interior angles of a triangle, gives you 180. Gives us BCA is equal to 63. So once we have those 3 pieces of information, we know that AC is the longest side. It's across from the largest angle. And according to the triangle inequality theorem, well, you can see what it says here. For question number 11, we used the triangle sum theorem to find 65. Then you should have noticed that RA was parallel to ST, which means these two parallel lines with a transversal between them gives us two alternate interior angles. This one's 65 and this one's 65. 65 and 48 subtracted from 180 gave us 67, which means that this is the largest angle, which means this is the longest side. So it's more and more just finding the missing angles and trying to determine which side is the longest. This was a little bit of a walk through the park, but take a look at it. A, B, and C is equal to 180, so we added them all together and we got a quadratic equation. Quadratic equation means we have to solve it for 0 and then factor it. You should have been able to factor this pretty easily because you passed algebra, remember? X is equal to 6. Why is x not equal to negative 30? Because generally we can't have negative numbers as measurements, and negative 30, if we plugged it into here, if we substituted it into here, that would have given us a very large negative number. We can't have negatives as measures. So here we got the angle to be 48. When we substituted in 6, this angle is 71, and this angle is 61. If this angle is 71, it's the largest angle, which means it's across from the largest side, or the longest side. AC is the longest side. And please remember, if it's asking us to determine the longest side of ABC, we circle that. That's the thing that it's asking us to do. After doing all this work, please don't forget to actually write the answer. All right, moving right along. This one is the problem set from lesson 7. Pause the video and then look back for the answers. In order to answer all of these questions, all you needed to know was the triangle side inequality, which is the sum of two smaller sides of a triangle must be greater than the larger side. Once you knew that, it was easy. Which numbers could represent the lengths of the sides of a triangle? Well, we know that 3 plus 6 is going to be 9. That's bigger than 8. Well, that doesn't work for this because 7 and 7 is 14. That's too small. 5 and 9 is 14. That's equal. No good. 2 and 1, that's 3. That's too small. We need these two sides, the two smaller sides, to be greater than the third. Same thing here. 17 and 6 is 23. That's bigger than 22. That's not the case for these ones. 5 and 13 is exactly 18, so no good. 8 plus 15, that's going to be 23. That's no good. That's too small. And then 17 and 6, that is 23. Too small. Again, well, this one is actually a little bit different because it says could not represent the lengths of the sides of a triangle. 4 and 5 is 9. That's bigger than 6, so that's good. We're looking for the one that could not. The one that doesn't work, 5 plus 5 is 10. That's too small. Same thing, we're looking for the one that could not work. 5 plus 2, that's 7. 7 is smaller than 9. Remember that the lengths of the two smaller sides of the triangle have to be bigger than the third. For question 5, they hid the true question amongst all of this talk about fill and tiles, but all we're asking about is which set of numbers could represent the lengths of the sides. Well, this one says it has to be scalene, which means option 4 is out because option 4 has two of the same sides. That's isosceles. The correct answer is choice 2 because 4 plus 5 is 9. That is larger than 6. 4 and 2 is not going to do it. 3 and 5 is not going to do it. Same thing here. Building a triangular pen for a pet rabbit. If it's 8 and 15, well, we have to do a little figuring here. 13 is a possibility. 13 would be the middle side, so we do 8 plus 13. That's greater than 15. If we choose 3, we'd have to add 3 plus 8. That's 11, not bigger than 15. If we choose 7, 7 plus 8 is 15. That's equal, no good. And if we choose 23, we'd have to do 15 plus 8. 15 plus 8, of course, is 23, which is exactly equal. It can't be exactly equal. The two smaller sides have to add to bigger. Number 7, it got a little bit more challenging because the numbers were larger, but that's not a big deal because you have calculators. 200 plus 300 is greater than 350, so 350 is going to work. All these other ones you'll find don't work when you add them together. And question number 8, it asks for the maximum number of different triangles. Well, just draw some triangles. Here's a triangle that's 2, 3, 4. 3 and 2 is bigger. 3 plus 2 is 5, which is bigger than 4. 4 plus 3 is 7, which is bigger than 5. 2 plus 4 is 6, which is bigger than 5. The only one that doesn't work, 2, 3, 5, because 2 plus 3 is equal to 5, not greater than 5. So only 3 different triangles are going to work. Take a look at the next page. I will give you the answers in a mere moment. All right, let's wrap up this problem set. In the diagram of ABC, it gives us all this information. It tells us part of AB, but it doesn't give us the whole thing. And then it asks for an inequality that represents the possible lengths of DB. Well, we're not sure what this side is because we don't know the whole thing, but we can make two different cases. And this is the same that we did in class. Case 1 is that AB is the largest side of the triangle because we're not really sure what X is. If it is the largest side of the triangle, that means that the two smaller sides have to add together to be bigger than it. That should make sense to you. Case number 2 says that AB is the smallest side, which is possible. This could be 6 and this could be, I don't know, like 0.5 or something like that. But if it is the case, that means that 7, which is the smallest side that's labeled, plus 6 plus x, which we said is the smallest side here, is greater than 18, because the two smaller sides have to be greater than the largest side. Both of those inequalities get solved for x, and then we say, well, x has to be less than 19, that's here, and x has to be greater than 5, that's here. Same thing goes for the second problem. We draw the diagonal, label it x, and we have two different cases. AC is largest and AC is smallest. If AC is the largest, that means 11 plus 11 is greater than x. If AC is the smallest, then x, being the smallest, plus 11 has to be greater than 11. Solve both inequalities, and Bob's your uncle. Then take a look at question 11. This was a challenge question. It asks for us to determine the values of x and y. Well, we know that all of these angles add together to 180. That's the triangle sum theorem. 4x is equal to 180, which means x is 45. Then I can solve using the exterior angle theorem to find y. Angle y is equal to 135. This is the last problem set that we're going to go over, problem set for number 8. Take a look at the questions and see if you can answer them. Then unpause the video and I will show you if you are right. All right, here it says that Hiro found centroid P by constructing the three medians. We know that a centroid separates each median into a 2-to-1 ratio. This one is 2x and this one is x. If the whole median is equal to 6, that means that 2x plus x is equal to 6. That's choice 2. For question number 2, it asks for the sides of a right triangle, which you should use the Pythagorean theorem for. We apply the Pythagorean theorem to all of these answer choices, and the only one that works is choice 3, because 49, 7 squared, plus 576, 24 squared, equals 625, 25 squared. For number 3, it talks about incenters. Incenters are angle bisectors intersecting together, which means that if this angle, this green angle, is 84, this angle in here is 42. And it is asking for BRC. BRC is this angle here, which means I'm going to draw a triangle that includes BRC, that I know the other angles. I know this angle here is 28, the whole angle. This is half of that 84 angle, so that's 42, and we're able to use the triangle sum theorem to solve that one. Last but not least on this page, fourth but not least on this page, in the diagram, DE is a midsegment. Midsegment means half of the opposite segment. If I'm trying to find the perimeter of ABC, I have AB, I have BC. This is the opposite segment to the midsegment, so if this is 7, this has to be 14. And now finally, last but not least, equidistant from the three walls. We're looking for a point that is the same distance away from all three sides, and that's part of the definition of incenter. The incenter is the point where it is the same distance away from all three sides of a triangle. All right, take a look at this last page. This is all about coordinate geometry. I'm going to show you the correct answers in a moment. Pause the video, try it, and then click back. For this problem, it asks you about a centroid. Centroid is a point on a median that splits the median into a 2-to-1 ratio. The 2 part is the one that's next to the vertex, and the 1 part is the one that's next to the midpoint. Since you know that, what we can do is find the distance from 7,2 to 2,5. That's the distance from the centroid to the vertex. That's the 2x part. That's square root of 34. And then divide it by 2 to get the value of x. Once we divide it by 2, we can multiply it by 3 to get the whole entire median, which means we take the square root of 34. We divide it by 2 to get x. And we multiply by 3 to get the length of the entire median. That was question 6. For question 7, it gave us vertices, and it asks us to find the coordinates of the orthocenter. Orthocenter is what happens when we intersect the altitudes, and this altitude, perpendicular to the bases, and intersecting the vertices, intersect at 3, 1. Here we were able to simply calculate the midpoints, and find the slope between mn and the slope between xy. Alright, that was a review of the problem sets from lesson 6 through 8. Good luck studying.